adding in a check to find out if it's done, it would make sense to put it in loop. So at the end of each frame, we can add in a check for win. So what that's doing is it's calling a function. We're saying, hey, did I win? So now I need to define that. So type a little bit, and now at this point I can define it. Say if, and at this point I need to say if score, and I will use a comparison operator, not a assignment operator. So I would say double equal sign. But as a practice, it's fairly common when you're checking, you say, if my score is greater than or equal to whatever that maximum value that I want is. Now, some practices of programming recommend that you never put an actual assigned value. So I wouldn't say like 10 if that was how many I wanted to win the game. I wouldn't put 10 here, but I would have a winning score variable or something like that, so that the variable is defined at the beginning of my program, so it's easy to then see where everything is assigned. It's always in one place. If I want to change it, it's easy to change. So that would be a way to do it. But for the purposes of this example, with single playthrough, we're just going to leave it as a hard-coded value. But know that down the road you may want to use an additional variable. Now, another advantage of using variables is it makes the code slightly more human readable. Because then I say if score is greater than or equal to winning score, it makes more sense than just this arbitrary number of 10 showing up inside my code. So there is some value in doing that, but for now we'll leave it like this. So if score is greater than or equal to 10, then we need something to happen. So at this point, what I would need to do is maybe if I had some winning game artwork and I could stick that on screen, I could maybe make all the ducks disappear. We need to figure out what we want to have happen, but for the time being I'm going to just send myself a message using trace. We have a winner. Oh, it needs a, gotta have an exclamation mark when you're saying we have a winner. Now I'm tracing out this message. It will show up in the output window. So I'll pop up in the output window and say we have a winner. What I need to do is I also need to make it so that the game stops. And to do that, I need to disable loop. I need to tell loop to stop running. So currently, my program says, hey, every frame, run loop. So what I'm going to do is I'm going to tell it to stop doing that. And the convenient way is I will copy that line. We'll paste it in. But instead of adding an event listener, I am going to remove. This says stop listening for enter frame and calling loop every time the movie enters frame. Because currently, up here, after setup runs, it says, hey, add event listener, event enter frame. Well, our movie enters frame 24 times per second. So 24 times per second, it calls the loop function. When I win the game, I want it to stop doing that. So I say remove event listener. Now, when you remove an event listener, it really is a best way to do it is to copy your add event listener, paste it where you want to remove, and then change the word add to remove. Because if it's not exact in the way it's written, except for the change of add remove, it will kick out an error. So now, if I run my duck game, we can try and get up to 10 here. think I need to modify the frequency of appearance because it's taken a while. We have a winner. Now the ducks are still flapping. Crosshairs is stuck. I'm moving my mouse and nothing's happening. And the score is still there. So it's done. It removed that. So it's probably not the best way to go about it, but we did a proof of concept. We proved it works. Making my button, I'm going to first create the button as a button object and then wrap it in a movie clip symbol. So I've highlighted my button artwork and I will call this orange. Now I'm going to change it to a button symbol like this. And now I'm going to take that button artwork and wrap it inside a movie clip. And now that one is going to get the orange button as a full name. And once again, under advanced, I can then say export for ActionScript. We can see it now appended it with the orange button over there. I hit OK. I don't need to see this message again. The definition for this class, blah, 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 blah. But because it deep freezed, my computer doesn't remember that I said I don't want to see it again. There we go. Now if I double click on it, we can see from scene 1, I'm now inside that movie clip. Double click again. Now I have the orange button. I have its up state. If I want to change it for an overstate and for a downstate, as long as I'm not changing the shape, I don't need to worry about the hit state, and the hit state will just be the shape of the button. Now I can take this overstate and I want it to become a much brighter color. And the downstate, I will turn into a darker color. So it has up, over, down. That's the button symbol inside the orange button movie clip, which is set to export right there. Now I'm going to take my artwork that I have here, call this winner screen. Export for ActionScript, it's a movie clip. So I have my winner screen, I have my button. Now I can just take both of those and hit delete, because I will then craft and position them with ActionScript. Now the win screen and the orange button are objects that don't exist dynamically like the ducks, where I create those inside a function. They need to exist outside of it so I can call them and get rid of them as I need them. That brings up something I didn't talk about previously, which is scope of variables. So like this duck, as it's referenced right here, occurs inside the enemy spawn function. If I ask Flash, hey, do you know where lowercase duck is in any other function besides enemy spawn, it will kick out an error because it will say, what's duck? It doesn't know, because I define that variable inside a function. It's not defined outside of it like scorebox or crosshairs. So crosshairs, I can access that in this function, I can access it in this function, and I could, any function can access crosshairs because it's created outside of a function. Any variables created inside a function can only be accessed inside that function. So that's a very common thing in virtually all programming and scripting languages. Variable scope. When a variable is defined inside a function, it can only be accessed inside that function, which is good because then I don't need to worry about kind of getting rid of it at a future date if I find I have too many variables of something. So now if I say var orange button, an orange button is a movie clip, and var winner screen is a movie clip. And once again, remembering that my variable name is often going to be a lowercase version of the ActionScript linkage name. So when I look at this ActionScript linkage name, I can see where that has the capital letter on it, and my variable name is going to be the lowercase version of it. You can use different names. So if I found that that was too confusing, I could use something like this, orange underscore BTN, short for button. So it's not the same thing. I used to do that a lot, but I've found that this is easier for me because I know exactly what this corresponds to in terms of this variable corresponds to something over here, but you have to be really careful with your naming. So you have to make sure that the library name and the linkage name match, and then the variable name is going to be a lowercase version of that. If you do that, you'll be in good shape. So now I need to define those objects. So orange button is a new, capital orange, button. And winner screen is a new winner screen. Now, orange button, its X is going to be probably somewhere around the middle of the stage, so I'm just going to guess at something. I'm just going to throw out a random number. I should have paid attention to, I should have put it on top of the windscreen and paid attention to where I wanted it, but I didn't. So I could go and calculate that, or I can just guess for now and figure it out. And the winner screen.x is probably going to be about 20 because it wasn't quite full size. And its y is probably going to be about 20. And we'll run this one and find out if that puts it in the right place. And if it doesn't, we'll adjust it accordingly. Now under check for win, I'm going to lower the value here. There's no reason to play it all the way through 10 if we don't have to. It makes sense to lower it down. So I'm just going to lower it down to 3. So once I get 3, the game's over. At this point, we could just simply say add child winner screen and add child orange button. So doing that is going to add those pieces of object or artwork to the display list, putting them on top of what's already there. So I'll save, run this. 1, 2, 3. Now, if you notice something, that when I put my cursor over the screen, the mouse disappears now. One, 2, 3. Now I get the mouse back. It has the nice little hand, the rollover feature. But my button doesn't have any functionality yet, so it looks like I got the winner screen in about the right place. But I do need to move the button over considerably, it looks like, on it. So the winner button let's try again. 1, 2. It's closer. thinking that's going to work there at about 215. So that puts it on screen. Now I haven't added any new functionality yet. And I haven't, well, the button appears clickable. It gets the hand, it has the rollover. I can push down on it. It doesn't have any functionality in it yet. Adding it in would be orange button dot add event listener mouse event dot click, and this will be orange click. So now I need to define that function, click, and it's tied to a mouse event. So when I click on it, we can say orange button dot parent dot remove child orange button winner screen dot parent dot remove child winner screen, and orange button, if it's going to disappear, really does not need to listen for clicks anymore, so copy paste that in, oh, wrong button, and then change the add to a remove. So we tell the orange stop listening for the click, remove itself. We tell winner screen get rid of itself, mouse dot hide, and now I just need to convince the game to somehow reset itself. But before I do that, what I want to do, and this is what's called kind of iterative programming, which is you don't add in all the functionality that you're trying to do for a major step at one time. You add a little piece in, make sure it works. Add another little piece in, make sure it works. Another little piece, make sure it works. Because if you add in more than one piece at a time without checking, then you don't know what's broken when you go back to figure out why the code isn't running. So if I run it again, 1, 2, okay, I have a winner. Go here, click, okay. Now, crosshairs aren't going, score didn't reset or anything. I want to run it again though and show something else. So 1, 2, 3, okay. Wow, that was a hit. Boom. Now if you notice, all the extra birds are on screen. So in addition to making the windscreen show up and the button show up, we might need to do some housekeeping as well, such as get rid of all the old ones. The construct that languages have developed for tracking a list of objects is referred to as an array. An array is a list. So I can have a list of names, Tom, Harry, Sally, and that means my array has 3 objects in it. There are 3 names. Tom is in position 0. Harry's in position 1. Sally's in position 2. So it's a list. That's all it is. It's just an ordered list of objects that starts counting at 0. Well, if I take my ducks when I create them and add them to an array, to a list, so I can store a reference to them, when the game's over, I can just cycle through that array and say, bye-bye, and delete the duck out of existence. And I can also go through that array and get rid of ducks when I click on them as well, removing them from the array. Now, working with arrays it can get a little bit confusing in the beginning, but once you get familiar with it, it's something that you realize for keeping track of objects inside any type of program, and it becomes just such a useful tool. Otherwise, every time I make a duck, I could refer to it, give it an instance name, and say duck1, duck2, duck3, duck4, duck5. But then I get rid of duck8, and I have to somehow know I got rid of duck8, and I have to then, well, then does duck9 become duck8, or does duck9 stay duck9? Yeah, it gets confusing at that point. So using the array is going to allow us to work with things a little bit easier. So I can construct an array, put nothing in it, and then every time I add a duck, it put it in the array. If I click on a duck, it pops that one duck out of the array. But then when the game's over, I can just say, cycle through the whole array and delete all the ducks in it, and it'll be like, done. And then I have no more ducks on screen. So that's the main logic of what's going on, and now it's just a matter of adding that in. So var duck array. It's an array, so I just start typing AR, and now we can see Code Hinting is helping me out here. Now I can just say duck array equals new array. So that now gives me access to an array object. This array is just going to be a list. I put the ducks in it, and I can now find out stuff about them. So let's go down to enemy spawn here. And every time I add a duck, I can say duck array dot. And now we can see that we have all kinds of options that go with arrays. Typically, when we do this, we're only going to use 3 of these array methods or properties. Just 3. We care about how long an array is, so we will be referencing that length. How many objects are in the array? Then, I am going to care about using push, which puts the object into the array, and we will use splice, which is where we get rid of an object in an array. And push takes, when I add an object to the array, it adds it to the end. And we could use pop, which would get rid of the last object in the array, but that's not going to help. If I click on one duck and that's not the last one in the array, then pop isn't going to really help. But if I use splice, I can say I want the object I clicked on to go and leave the array, and then remove its place in the array. So what was object, say, if I click on 8 and pull 8 out, what was 9 becomes 8. So I will use push. So we just stick this duck into the array. It just pops it at the end of the list. Now, what I can do is say duck array. Oh wait, I want to trace it. And we'll just trace out the length of the array. This will just tell me how many ducks are in the array, and I'm going to make it, well actually, we'll just let this get a little bit higher so when we do play it's easier to have it happen. So if I run it, there's 1 duck, 2, 3, 4. So we can see how many objects are in the array. So I got up to 11 ducks. So it's adding those objects, or the ducks, to the array. So this now means all my ducks are in the array, and I can gain access to them. Now there's a common technique for removing objects by cycling through the array. And the first time you see it, it'll be like, whoa, that hurts my head kind of code. And you probably won't be very fond of it. What you will realize is after you've used it 2, 3, 4 times, you can just copy paste it from a previous project, change the particulars, and you're up and running. So you'll know it as the kind of the main piece for doing it. Which at this point, I'm realizing to continue like previously, I will save also as a new file before I start deleting things from the array. So now, when I win, I need to start grabbing all those ducks and getting rid of them. We get rid of the ducks by using what is called a for loop. A for loop is for, and what we're going to do is we'll say a for initial condition, and then while a certain thing is true, then we will decrement and we'll see how it works. So I'll say var I, and I is an integer, and it will be equal to. Now, when we're dealing with objects on screen and cycling through a list of objects, often it's going to be useful to kind of go through the list of objects from the end of the list backwards to the beginning. And when we start having more complex projects where you're checking to find out if one object collided with another object, if so, you're going to delete one of those objects from screen. And that type of operation, when you're tracking those objects, works by cycling through and checking, did object 1 hit object 2? Did object 1 hit object 3? Did object 1 hit object 4? So you cycle one object versus all the other objects. Well, if you're going through that list and then you realize it hit 1, you pull that out of the list and want to continue, well, then the next object moves down the line to replace the one that's pulled out, but you already checked an object in that position, so then you jump to the next part. So there's this kind of skipped object problem that occurs if you're going to be removing objects and counting, starting at object 0 and moving upwards through the list. So the recommended practice is to work backwards, because we're just getting rid of all the objects and we're not going to kind of check and remove one object and then move on to the next, and then maybe not move to the next one, but we're removing everything. We could go forward, so we could start at 0. So we can say we'll start with I at 0, and then we will have, well, I is less than duck_array.length. Then we will make I get bigger. So each time this loop runs, it starts at 0, does what it needs to do. Then I becomes 1, it cycles through. Then I becomes 2 and cycles through until I is greater than the length of my array. That's how that's the logic that's being read here. So at this point, we can get rid of an object by saying decorate@splice, and now we say what position in the array here goes. I can't get the forward version to work, so I'm going with the reverse direction. So I set var I equal to the length of the array minus 1. That's because if I said the length of the array and said use that, we have to remember that arrays start counting at 0. So if there are 10 objects in an array, the 10th object is at position 9, because arrays start 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I say var I is equal to the length of the array minus 1. I, and then while I is greater than or equal to 0, and then the next loop through it will be effectively it's the length of the array minus 2, and it just cycles its way through. Then we say duck array, and we'll just use I, whatever that number is, which starts out, if our array had 10, it would start out at 9. And it removes that object, where we say, and the square brackets are how we access an object at a specific position within an array. So if I have 3 objects in an array, I could have 0, 1, or 2 as possible values for I. So we say that object, have its parent remove it. And then we use the splice, which says remove that object from that position, and we're removing one object. Splice is a cool command because I can actually use it to remove more than one object, starting at a specific value, or I could remove it. So it's a pretty powerful command. But the issue we're running into that it was giving the error messages is that when I click on a duck, it was removing the duck from the stage, but not removing the duck from the array. Because of that, when it went through here and said, hey, grab such and such object in the array and remove it from the stage, well, it's already been removed when I clicked on it, so it was freaking out. And that's what the can't. So if I leave these lines commented out down there and run it, let's get a few ducks. So this is waiting for me to have 4 clicks, 3, 4. Now it's giving me an error message going, whoa, I can't get rid of those ducks over there because it's trying to remove child objects in the array that have already been removed. So what I needed to do is and I could probably write this as a single line of code, but it's easier to create a kind of a temporary variable, index, and it's equal to the object that I'm clicking on, its position in duck array. The index of refers to the position of an object in an array. So the object at 0 position would return a value of 0. The object at the 1 position would return an index value of 1. And then I say duck array splice, and then I say index, that value up here, and then I'm removing 1 duck. And then I go and remove it from the stage. And in doing this, now I don't get any error messages. Waiting. There we go. 1, 2, 3, 4. Have a winner. Look, there it is. My game hasn't reset, but at least now I have a winner capability, or I can at least clean up at that. So, progress. Progress is being made. I'm going to take an add loop to try and I'll copy it. Go down here. So let's see, under orange click. And remember, I'm just realizing that under orange click we wanted it to be mouse touch show, not mouse. Isn't it mouse touch show right there?
Mouse touch shows up.
So we just put loop back in when I click on the button. 1, 2, 3. I can't end the game. There we go. Now we can end properly. Have a winner. I broke it. So the reason it broke, because if we comment this out, it makes it go away, but the reason it broke, if we look here, loop says make the crosshairs move, check this board, reset the, or change the text in the score, spawn the enemy, puts the crosshairs on top of any enemies that would spawn, and then it calls check for win. If we remember, every time I clicked on a duck, what happened to my score? goes up by 1. So the moment loop runs, what is my score still? It's still a winning score, which means I automatically put those screens back, puts it back on, because I never zeroed out my score. So if we're going to do that, we probably need to then zero out the score before we tell loop to run. Score equals 0. So now doing that, 1, 2, 3, 4. We have a winner. Click. Score is now 0. It's moving again. 1, 2, 3, 4. Now I'm thinking I want my score thing to be smaller and appears lower so I can still see what the score is when the win screen comes up. It's going to require me to create a couple more variables. Start screen. Our blue button. Now, there's a couple ways I could go about this. Is I could have my blue button object, and then I can, as a movie clip, and then I can attach to it a blue button down or a blue button over or a blue button up. So we can go about it those different ways, because otherwise I can say up. We'll start out with the basic one, and then we'll add the different states to it. And because they're all the same size, we can just kind of keep adding, which can make it be a little bit easier. So now I have my start screen, I have my blue button. Now, my start screen would be start screen equals new start screen, and blue button underscore up equals new blue button underscore up. Now, if you find that you are prone to doing a lot of typos when you type in code, having verbose names for all of your variables and objects and things like that makes the code more human readable. But if you find that you do too many typos while you do it, I would encourage you to perhaps use very abbreviated naming schemes, because that can allow you can get your typing done faster with fewer errors. But it kind of depends on how you work. So start screen dot x equals, so now we need to set start screen's x equal to 30, its y equal to 30, blue button dot x equal to 1 to 200, and blue button dot y 60. Okay. So now I have some values for my items. But now a conflict that I'm going to be running into here. Currently, setup starts the whole game. We want setup to add the start screen, and after I click on the start screen, we want it to then get rid of the start screen and then add in the game. So this is where we're probably going to need to eliminate or move some of the items from here and put them into start game function or something like that, which we'll get to in a little bit, because this is starting to become a little bit unmanageable as I have too many different things going on here. Now, it's not too bad to have all of these what are in essence kind of static objects, and I'm going to move them around a little bit to start making sense out of organization, because telling the stage to be listening for clicking, that's part of the game, so we probably don't want that going on yet because the game hasn't started. So what's going to happen here is we're probably going to move a whole bunch of things around. And as was said in the previous video, you can say make all of your objects, then give objects X and Y's, or you can have the X and Y for each object tied to each. So we do start screen, then blue button, then orange button. So you can kind of decide, do you like to make all of your objects and then position them, or make an object, position it, make it. It really, there isn't an advantage going one way or the other on that. So currently I'm making all of my items that I'm going to use, but I don't want to add game-related items to the stage just yet. I don't want to hide the mouse just yet. Score would make more sense to make that part of starting the game, that we reset that down to 0. And these are getting the game ready. So at this point we're starting to see a little different organization happen with it. That up, we can just put this. So I have all of my visible objects here, the duck array, but this, all of this information, this is really the game. So we don't want that yet. That needs to be in kind of like a start game sort of function. So we're going to have to move that in a moment. But what I probably want is blue button, add event listener, mouse event dot. Now, this is where I have my different button states. Technically, when this button, I want when I roll over it, I want it to do something, and when I roll out, I want it to do something else, and when I mouse down on it, mouse up, oh my gosh, that's a whole bunch of different functionality things that are all included into the default button object. So what we're probably going to realize is we could add an event listener for each one of those events, and then code what graphic you want to show at each one of those. And that's how you used to have to make an interactive button style object, is you had to have an event listener for each state, a function for each state, and then define what you wanted to have happen and which piece of artwork you wanted to have happen at that state for the button. So the different states we're looking at are mouse down, mouse out, mouse over, mouse up. So, wow. And then mouse up outside, which if you push down on a button, move your mouse outside the button, let go up outside the button, that registers yet one more event. Yuck. So even though we started down this road, I'm going to actually say maybe we don't want to add all those listeners in and stuff, and we'll just use the default button object this evening and go with it. You make a button object, you take that button, you wrap it in a movie clip symbol, and then that's what you add to your project. So it's a two-step process versus 6 event listeners and 6 functions. If you work in other programming languages, you often have to do those. You have to listen for each event and then code appropriately for each event. Not very fun. So when Flash introduced the button object, there was much rejoicing because it simplified the task of making a visually interactive button object without having to do a ridiculous amount of code. So currently I'm just going to have it tied to mouse up. No other reason than I can. Oh, and then the function it will call will be blue click. So now I need to figure out what blue click is, and then we'll have to move a bunch of stuff out of here shortly. Function blue click. Still a mouse event. And now under blue click, we need to say start screen dot parent dot remove start screen, and then blue button up dot parent dot remove it gets rid of itself. We could tell it to stop listening for being clicked on, but it's gone, so we'll be able to live with it for now. So that gets rid of that. And then I could say load game. Function load game. And this would be a fantastic place to put all of that stuff. So that adds the child of square box and crosshairs, tells crosshairs not to listen for mouse clicking, hides the mouse, sets the score to 0, tells us to start listening for dot click, and adds loop. So we've now broken it up that in some ways setup is a much more understandable function. Creates the objects and gives objects that will have fixed positions a location. And then it tells the first object to listen for clicking. If I click on that object, it gets rid of the start screen in itself, calls load game. Load game then adds the score box and crosshairs and blah, blah, blah. So now it looks like we are on target to have absolutely nothing happen. And nothing happened because I never added blue button up or start screen to the stage. So it makes it kind of hard for them to show up. So I never said add child screen, and I never said add child blue button up. Let's try again. Boom. Oh. There we go. 1. We have a winner. Alright, so now I have a playable actual game, but I think then it was 160 for my blue button. There we go. Now if you notice, when I roll over that blue button, it doesn't do anything. So in the same way that with the crosshairs we said mouse enabled false, we're going to use a similar kind of language on the blue button and say blue button up dot button mode equals true. And this tells it to give it that hand feature when we roll over it. So it looks more like a button. It doesn't have the rollover part because we're not coding mouse over, mouse down, mouse up outside, and all that other stuff. But it's working. And once a duck appears, boom. Now I have a winner. I can now keep playing this to my heart's content.